Okay, so this question basically says the equation x to the 4 plus 2x minus 8 equals 0. And if we go back to our question, which was our graph, which is here. There it is there. So we've got this function x to the 4 plus 2x minus 8, and we are going to work out the exact value of that point there using Newton-Raphson. We're not going to use bisection, which is what we did yesterday. When we did the halving and halving thing, we did a few iterations of that and we got whatever we got. We're now going to use Newton-Raphson, and we're going to start, the question says, start at the position x equals 1. Now, how does the Newton-Raphson method actually work? I described this on Monday. Newton-Raphson, how does it actually work geometrically? I know I talk to myself a lot, but I didn't realize quite how much. So, how does this work? Geometrically, it works on tangents. Yep, brilliant. That's a good start. Newton-Raphson works on tangents, and we're going to start at x equals 1, which is here, where that dot is. And that means our first, geometrically, we find the x equals 1 point, which is there. And then the formula effectively does that and says a better estimate of the answer is where it cuts the x-axis. That's what Newton-Raphson does. So it starts, Humphrey, you need to watch this. We start at 1, our first tangent, where it cuts the x-axis, that's our first approximation. The formula will come up with this number here, yeah. And our second one goes from here, we go up to where it cuts the axis, which is up here somewhere. And the tangent for that sort of does nothing like that. That tangent, in fact, still nothing like that. I'll just move it. It's probably more like rotate. Like that, that's sort of better. So this point here, so let's do this. Let's do this again. We start here, which is there. We go down to where it cuts our graph. The first tangent is this one here. It cuts there. That's our first approximation. The formula then finds where it cuts the graph, and that blue line there is meant to be a tangent to that point, and it cuts there. So therefore it is slightly closer. Okay? And then our next tangent is where that point meets the graph is there, and the tangent goes through there. And basically you can see that as soon as we're this side of the answer, the tangents are going to zoom in on the answer very, very quickly. Okay, that's the method. And it looks a mess, but that's actually what's going on. So geometrically, that is the deal. So now, how do we use this? F of xn, this refers to our formula, which is x to the 4 plus 2x minus 8. That's f of xn. Okay, y equals f of x, it's the same thing. Okay, f dashed of xn is the first derivative. In other words, for those of you who are new to calculus, calculus is a process, or differentiation is a process, which, as far as we're concerned, just takes one function and turns it into another one. That's all we need to know. It's to do with gradients, but We don't need to know why or the details, that's just how it is. So this is the process of differentiation. You take the power, bring it down the front, reduce the power by 1. So x to the 4 becomes 4x cubed. The 4's gone down the front, the x to the 4 has become x cubed. Now 2x is 2x to the power of 1. The 1 comes down the front. To join the 2, it stays as a 2. X to the power of 1 becomes x to the power of 0, and x to the power of 0 is effectively 1. So x to the 4 plus 2x minus 8 becomes 4x cubed plus 2, and the negative 8 just vanishes. That's differentiation. Yep.
Maybe a stupid question, but does that stay the same when you just substitute the x value?
Yeah. I'll show you how to substitute in a moment. So f of x is our function. F dash of x is our first derivative of the function. It's called f dash of x. Yep, George?
Why is it this shows the positive x-intercept rather than the negative one? Like, will it sometimes show the negative?
Absolutely, yeah. The sign, yeah. It'll work out both. Now, xn, so let's just substitute this in. Now, before we go any further, xn, the n plus 1 and the n, what this refers to is xn refers to our first, or our, here's our question here. We start at x equals 1. So that is our first one that we're going to use for x. That's our first value of x. But when we've worked this guy out, x to the n, x minus f of x over x, once we've worked this out, whether obviously on our calculator, the result is our next guess, which we call, if we start with x1, it's going to be called x2. And then what are we going to do with x2? Chuck it back into our formula, work out x3, and x4, and x5, and x6, and so on and so on and so on, which can be done very, very quickly on your calculator. So the point of this is that to generalize the function, we say xn, meaning any one of your guesses. If we substitute it into this formula using xn for the x, in other words, using whatever the hell we're using, then this formula comes up with xn plus 1, which refers to the next one. That's all it is. Okay? So let's just do this for this one here. We can write down, I don't use xn plus 1 and xn, I use x1 and x0. x1, in fact, because we're told x1 is, we'll use x2 and x1. x2 is equal to x1 minus f of x1 x1 refers to, in our case, x1 refers to the number 1. There it is. The number 1 is our x1 because it says x equals 1. It's our starting value. We're going to put 1 into our formula. Okay? So our formula is this. There it is. In fact, I'll just get rid of all that. And I'll just put x2 equals x minus x to the 4 plus 2x minus 8 divided by 4x cubed plus 2. There it is. What should we do next, Humphrey? I'm going to keep asking anyone who's not watching.
You should put the one you got from x1 into the x value.
What's x going to be for the very first round of this calculation? 1.
Whatever it told you it wasn't.
Yeah, and you should have known because I just talked about it.
Oh, no, I wasn't.
Well, you didn't know the answer though, did you?
But if you put 1, you won't get the number you put in x2. And then you put x2 into x.
Now, if we put a 1 in here, because it says to put in a 1, we get all of that. Work that out, please. Do it in your head if you want. 1 minus, that's negative 5 over 6, What's that? As a fraction. Or as a decimal, please yourself. 1 minus negative 5 over 6 is?
Negative 1 over 6.
1 and 5 6 maybe? What's 1 and 5 6 as a decimal?
This is minus negative. 1 and 1.83. No, that can't be right.
What's 5 6 as a decimal?
1.8333.
Which is 1 and 5 6 basically. So that means, going back to our diagram, which is now not there, the x equals 1 position, the tangent from that x equals 1, where it cuts the curve, that tangent flies up and cuts at 1.833333. That's where it cuts.
So you put that into x1 again.
Correct. And this is the iterative process, which is Newton-Raphson, is that you work out this guy, which is your first real guess, because let's face it, you were told to start at x equals 1. The formula gives you 1.83333. There's your first iteration, and so we take the 1.833 and put it back into here again. So we put a 1.833 there, put 1.833, work it all out, and that gives you x2 or x3 or whatever letter you want to call it. It gives you the next one and then the next one. And if you keep substituting in, after 3 or 4, you will start getting the same thing over and over and over again, because the tangents will have rushed into the true answer. Yeah.
So can you just do 1 or 2 and then do the rest of the calculate? Just the first 2, like, show what you do?
Well, yeah, you don't even have to show as much as I've shown you there. I've just shown you to illustrate the process. All you have to do is do a little table saying, you would say, okay, I've got my x's, and I start at 1, and the next one is 1.8333, and you, as long as you list them, you don't have to show any working whatsoever, because you're not expected to. You're meant to just do it on the calculator. Yeah, you just do it on the calculator, but you have to show the progression of the numbers. You can't just write down